Okay. So k-means clustering typically is a non-unsupervised algorithm. Unsupervised means you don't provide labels to the algorithm. You just provide data. It is up to the algorithm to, or the, it is up to algorithm to find relationship between data and put them together. So that is what clustering. K means k nodes. So k clustering.
Mhm.
Okay.
Okay. That the idea about k-means is the idea about unsupervised machine learning is you try to find relationship between the data.
Okay.
Okay, you try to find relationship between the data. That means you have the data, and what you have to do, you have to find relationship between them. Okay, this is very useful in market segmentation. You have the market, and you have okay, and you'll have to understand how to group different customers into different buckets. Got it, right?
Okay.
Okay, suppose you are hypercity and you want to find 3 groups of customers so that you can plan different advertisement marketing tactics for all of them. You can do that with unsupervised. Suppose you have satellite data. Okay, you want to group similar content one side. Okay, you'll use typically to find relationship between data, and when you don't know anything about data, you'll use unsupervised algorithm. Understood it? Right?
Yeah,
Okay.
yeah.
Okay, so I'll show a few more things. Let's first see the algorithm. I'm sure at this point you have a vague idea about unsupervised. Let's see this algorithm. Okay, then I will be showing you. So this is a visual. So you can see k means what you want to do. You have all this data here. Okay, just imagine this data as x and y coordinates. Okay.
Okay.
Okay, so what you have to do here, you have to divide all this data into 5 groups.
5 groups.
Yeah, since we have to divide 5 groups of this data. Okay, so you randomly chose 5 points. The colored point you can see here, right?
Yeah.
Mhm. Mhm. On what basis we will choose this?
Randomly.
Okay.
Okay, now you'll start it. First you have to group it. So what it does, for each point it will try to find point which is closer to it. Oh shit, it did actually all the thing restarts. Okay, for each thing it has to find all, I mean, for each point, whatever white points are there, it has to find the closest centroid. These are known as centroids. Okay, got it, right? Okay,
Yeah.
the next step is, this is the cluster here, the bigger thing. This is the cluster.
Mhm.
This is a cluster here, right? This is a
Yeah.
cluster. This is a cluster here. So what it has to do is, okay, what it has to do is it now has to find mean of each cluster.
Mean of each cluster.
Yeah, what is mean of each
Okay.
cluster?
Okay.
That means, just imagine this as vectors, all of these points as vectors. Okay, initially you connected all these points to the nearest centroid. After that, for all the points you are finding mean of all the vectors. Okay, mathematically what this means, you want to find a point. Okay, if after finding the point, sum of all this distance is least compared to all other options. Okay,
Didn't get.
so
Can you repeat once again?
yes, I'm repeating it. So I'll restart this, and I'll remove this clutter also. Okay, so first step is you have some points. Find, for each point you will find the nearest cluster centroid. Okay, for each point you will find the nearest centroid.
Okay.
Okay, after finding the nearest centroid, as you can see here, what is the next thing it is doing? Okay, what is the next thing it is doing? It is actually doing what is actually doing for each. This is a cluster. For each cluster, this is of course
The
least.
centroid.
This is the centroid. Now, what you want to find? You want to shift the centroid to a better position, such that sum of distance of each point to the centroid, sum of all the distance of each point to the centroid is least. This is called centroid recalculation, or finding mean. That means if you find means, that will be at the best distance from all of them. Understood?
Yeah.
Is this something like that cost function only?
Exactly, you guys nailed it. Good.
Okay.
Okay, so that's what actually I was using those words so that you can point me towards that. Okay. Okay, so here you can see this. This is similar to your logistic regression. You have here, the same cost function here. What is the cost function? You can see, you remember this syntax. This is the distance. This is the centroid position. This is the vector position. You're finding square distance, right?
Yes, yes.
There are two type of distance. One is L1 distance, one is L2 distance. L1 is mod of it, L2 is square of mod of it, right? Okay, so what you have to do, you have to find the best value of coordinates of the centroid such that it is at the least, such that the cost is least, isn't it?
Yes.
Yes.
Okay. Technically that is what it is. So you continue this thing. So after you found the centroid, again you shifted the centroid, right? So what will happen? For each point you will again calculate, is there a better centroid? And it will again associate with, that's what happened now. After reassociation, you will again find mean of the cluster. After again finding mean of the cluster, you will again recalculate if there is a better centroid for a particular point. And there is again reassociation. Till what time will you be doing this?
The mean square of them get reduced, minimized.
Yeah, but what time? Till the time there is association and reassociation happening, isn't it?
Yes. Yeah.
Yeah. Here also we can calculate like that, d by dx is equal to 0.
No, actually, I mean, yeah, we can say that. I mean, you can put all the cost in the gradient descent and then you can find it. Yeah, you can do that. Yeah. Understood, right? The algorithm.
Yeah.
Okay, so this is what your k-means is. K-means, where is k-means used? K-means is typically used to find, centroid of a cluster. Fine, right?
Okay. This we use in mainly on unsupervised learning.
Absolutely, you use an unsupervised learning. And what are the other business cases for this? Market segmentation, social network analytics, astronautical data analysis. This is satellite data. When you get data from satellite, you mostly don't know what it is. So whenever you don't know anything about the data, you will be using unsupervised learning. Got it, right?
Can you explain brief more, like how it is used?
In satellite data. Yeah, I am explaining. Yeah. So see, satellite data is mostly, you will get data about which you don't know anything, right? Okay, so what will you do? You will first do unsupervised algorithm clustering. So that similar type of data comes in one bucket. Got it, right? Okay. After you did this clustering, now you suppose you know something about one cluster. You know that okay, this colors means this is ocean. So you can almost do conclude that all the data which is similar to this means those things are water bodies, isn't it?
Yeah. Okay. Segregating the kind of
Right.
different
If you have
objects.
slight information using clustering, you can get some more information.
Understood. Okay.
Okay. Now let's see. Okay, now let's see, understood the cost function and all these things, right? Now one important aspect is, how do you choose the centroids? As of now I'm choosing them randomly, right?
Yes.
Okay, so how internally does it? You don't have to do choosing centroid and all that. Internally the algorithm chooses for you. Okay, what it does, it multiple times to randomly chooses the centroid, then see which one is working well. I mean, which is the centroid using which you are getting the least cost. Got it, right?
Okay.
Okay, so that is what algorithm does. Now the next question, understood, right? How to choose centroids? You don't have to bother, algorithm will be itself do it. Okay, and how it does it? It does multiple times choosing the random things. It finds out the best possible centroids for. Okay, the next thing is how to choose number of centroids. Very important case, isn't it? Because as I was telling you before that okay, great, that you are giving number of centroids as 2, number of centroids as 5, whatever you are giving, but that is based on your understanding of the data set. Many times you don't know how many possible clusters are there, isn't it?
Yeah.
Okay, in that case Okay. Okay. In that case, what happens? You use this technique, elbow technique. Okay. What happens in this elbow technique? You understood, right? If you choose some number of centroids, suppose you are choosing one centroid. Okay, there will be a cost function associated. How to find cost function? You understood, right, from the previous discussion?
Yeah. Yeah.
Mm-hmm.
Okay. Now, if you choose one centroid, this is the cost function. If you choose two centroid, this is the cost function. If you choose three centroid, this is the cost function. If you choose four centroid, this is the cost function. So you are plotting a graph for centroids with respect to number of centroids, right?
Yeah.
Now, okay. Now, what is the ideal number of centroids? Ideal number of centroids is that number which is actually having an impact on the cost, isn't it?
Yes.
So till centroid 3, you are actually really dividing the data. After that, there is no substantial reduction in the cost. That means even if you're creating a new centroid, it's not saving a lot of your cost, right?
Correct. Correct.
Mm-hmm.
Yeah.
So ideal number of centroids is 3. Understood how to find ideal number of centroids?
Yes.
Okay. Understood
But
all the mathematical things so far. How do you find number of centroids and all?
yeah, understood. But anyhow, reduction is reduction, right? Like cost function got reduced at 8th point also.
Huh? Yeah, cost function reduces at the 8 point also. But if you add a number of clusters, is it really separating the data? I mean, the idea was, finding similar data in one bucket. But if you definitely add one more cluster, one more centroid, that is not really, impacting the cluster. Maybe you are separating similar data itself. That is why no significant decrease in the cost. Understood?
Mm-hmm. Mm-hmm.
This over predicting graphs are there, right? When we
Overfitting.
overfitting them,
Right.
like that.
So like that, yeah, there is no significant benefit you are getting out from here. Okay, so that means okay, you are decreasing the cost, but not. That's why this is known as elbow method, very popular. Fine, right?
Yeah.
Now,
Avanti,
haha.
why to switch the centroid from centroid is nothing but we are taking one another node, right?
Hmm.
We are randomly selecting one node
Hmm.
and we are creating that as a centroid for the cluster, for one cluster,
Right.
right? Why we move it again? Why to like we already have segregated data now. Once we made a cluster, is it
Come again. I'm not able to follow you.
okay? In the above, we have shown the example, right? We have shown the example, right?
Mm-hmm.
Where you have select out of 100 nodes, you have selected 5 nodes as centroid,
Right.
right? 5 nodes as centroid, and why why we want to find the minimal cost function again?
No. 5 you're using, but maybe 6 is a better case. How do you know?
Okay. I don't know.
Right. So that's why you will try for 1, 2, 3, 4, 5. In our case, I mean, we have almost started with 5, but I can do this 2 also. Okay, only 3 centroids. Sorry. Yeah, now you have only 3 centroid. 1, 2, 3.
Mm-hmm.
Right. So you can see this is an ugly selection of centroids. So you'll do like this, like this, like this, like this, like this, like this.
Okay, okay. Like this. So that okay, what I thought before is
Hmm.
when we decide a cluster,
Hmm.
so only those points will be matched with the centroid. I thought. Now when I see this, I got to know. the nodes will move from one cluster to another cluster, right?
Right,
Nearest
right,
cluster.
right. I mean, it'll be based on the algorithm which will find the nearest centroid, right? So it will keep on
Okay,
changing.
okay. Yeah,
Got
yeah.
it, right?
Now I got it. So
Okay.
by using this, we will surely select segregating similar kind of data for
Right,
one cluster.
right. So all these data are of similar kind. So something you
Okay.
could sell to this guy could have been sold to this guy.
Mhm. Yeah, yeah, yeah. Understood. Understood.
Okay. Now let's see the next thing.
And how to find this modified centroid
So
point?
yeah.
X
So
coord.
let me show the code for you now. Okay. The modified centroid will be mean of the all the vectors. Understood, right?
Correct. Vector content x coordinate and y coordinate
Y
as you.
coordinates. Right.
Okay. So for a centroid, it
Hmm.
has one x and y coordinate, and the next point, which is a vector, it
Hmm.
also has a x coordinate and y coordinate.
Hmm.
Now I should have to make x to x, x of centroid and x of vector whole square, or and y to y whole square,
Hmm.
like that.
Like that, yeah. And you'll try to find that particular coordinates of the centroid which will be at the mean. I mean, see, if you have to find mean of the centroid, what you have to do, you have to simply do this, right? You have to do this, isn't it? You have
Correct.
to minimize this cost by changing value of this centroid, right?
Yeah. By
And
Yeah.
changing
Yeah.
the value of centroid. Correct.
right, and this is the distance between this is the centroid and this is the actual point. This is the distance. This is what you calculate, and what you have to do, your sum of all the vectors in the cluster, you have to minimize it. Okay.
Mm, mm, mm.
Okay, so mathematically it is this. In our advanced course we'll actually do it in TensorFlow in the skill level, but if you have understood this, we can very easily understand how scikit-learn is doing it, which is very easy actually. Okay, let's see.
Okay. Yeah.
uh,
Avantik, just one point is when we are telling this unsupervised learning to be used in whatever you told in astrophysics and those kind of things. So we are not treating here as like only two-dimensional figure. It should be like x, y, z.
no, of course it can be any dimension. I just show two dimension because
Okay.
in screen I can show only two dimension. It can be any vector. It can, as
Okay.
here I am doing image comparison now, so it can be of any
Hmm.
size, right?
Okay.
Okay,
Okay. Fine.
see, you remember digits data.
Yes.
Okay, so I now have digits data. As you can see, it's 1797 digits with 64 vector size, isn't it? So what is the
Yeah.
vector size here? 64, right?
8 x 8.
Yeah, so 64 vector is the vector size.
Mhm.
Now what you're doing here is simply creating the model, and here you're telling it, see, this is digits data, right? So 0 to 9, total 10 digits are there and clusters.
Mhm.
Okay, and we have this random state is equal to 0.
Okay.
Okay, we have this random state is equal to 0. Now when you do this k means dot fit, okay, k means dot fit, if you do what will happen, and you are not passing any label here, or you are passing only this data here, right? You remember, right, the data about.
Yeah. It is
Okay,
an image.
right, this is the data. So digits data you're doing, and this is the digits target, what you have, 0 1 2 3. Now after training the model, you want to predict for all the data. So k means predict digits data you're doing. So this is the cluster number. So okay, so what is the output of prediction? Training is you're passing digits. Output of prediction,
Mhm.
there are 10 possible clusters because you have configured here 10, right? Okay.
Mhm.
Yeah.
Okay, and what is the prediction outputs, you're again passing k-means is the trained model. Your prediction output will be between 0 to 9. That means the cluster 0 to 9. This part is clear,
Yes.
Rupesh?
Yeah.
Okay, remember cluster 0 does not mean digit 0. It means any cluster, I mean, or any similar type of data getting clustered into 0. Understood, right?
Correct.
Okay. Now cluster is, I want to find what is there. You see the 0th data is getting classified into cluster 5. This is your 0th data. Remember, 0th data was like 0, actually 0. You can see this 0 here, isn't it?
Yeah.
Okay. So
Okay.
now
Can this be shown? Can you show the clusters?
I'll show the cluster. I'll show. It's here only. I'll show. Okay. This is the cluster. So there are, what is the output of this? There are 0 to 9. That means total 10 cluster is the output. You can see cluster number here. Okay. Fine, right?
Yeah.
Okay. So after seeing the cluster number, you want to see what are the contents inside cluster number. Okay. I will first show you centroid of the cluster 0. Okay. So this is, I'm dumping here. So what, how do you print the cluster centroid? Like k means cluster centers. It will print all the centers. Understood, right?
Okay.
And you can see here, this is cluster 0 which is getting printed here. This is cluster 1 which is getting printed here. This is the centroid of each cluster.
Centroid of each cluster.
Understood? Because a cluster with lot of 4 will have sort of 4 in the centroid, isn't it?
Yeah.
Okay. So this is your cluster 0's content. This is your cluster 1's content. This is your cluster 5 content. So what is cluster 5? Cluster 5 was actually 0, isn't it? You can see here.
Cluster 5 centroid is 0, right?
Exactly. So that is what, see, this is your data. Target was 0 and this is that cluster number 5, isn't it?
Yes.
Okay. So this is just by seeing it, but if you want to really find out what are the contents inside cluster 5, how do you find out? Okay. So just one thing you understand, right? Cluster 5 means whatever majority of data will be of similar type. This you understood?
Understood.
Okay. So so there is a function from scipy stats import mode. Okay. What it will do is it will find, like you have this data where lot of data is 1 and it has 6. So it will return you the value which is repeated here the most number of times, like 1. And how many times is it repeated? It is repeated 5 times. You understood what is this function?
Understood.
Okay. Now what you will do, you will find out int 5, right? All the index of the data, mp where means index of the data where cluster is equal to 5.
Okay.
Okay. So this int 5 is index of the data whose cluster is equal to 5. Now if you pass okay, so int 5 will be the index of the numbers whose cluster is, let me run out of it. Okay, let me run it. Okay, here int 5. What is this? You understood? This is all the, okay, this is all the indexes which belongs to cluster number 5. Understood?
Yes.
This is index number 0 data. This is index number 1. Okay, so now what you want to find out among this index? So this is all the index number. So Okay, so you have data dot target. This is all the index number. So what will be this?
This will be the data number.
Hmm?
Digits.
So this is the actual target value of all the nodes which are getting classified to cluster number 5. Understood? Okay,
No
so you can
accuracy.
see,
Only one is changed.
see, if you hear, these are misclassification, isn't it?
Yes, 2, 6. Yeah.
Right? Misclassification. That
Yes.
means these are wrongly getting classified over here.
It should be 0.
Right, it
Yes.
should be 0. So if you have to really understand what is this entire content, like you can say that, more majority of them is 0, that means it is 0 only, isn't it?
Right.
Okay. Or if you really want to get it, you know, like the way we did earlier,
Mode.
mode, yeah, I have an
So,
import.
yeah, in that case, mode will help.
Yes.
Yeah.
This will tell the accuracy, right? For this.
Why is it not executing?
You have given mod, not mode.
Oh, sorry. Got it, right? So here 0 is appearing 177 times. So 0 is in majority, that means it is cluster number 0. Right? That means cluster 5 contains 0. Understood?
Mhm.
Understood. So now you have decided that so digits will be there from 0 to 9. So you have decided cluster 10 clusters. So
Huh?
it is working fine now. Like you know that we know that digits are there from 0 to 9. So we
Hmm.
have taken 10 clusters. So it is
Hmm.
working fine.
Hmm.
Uh, so this is the appropriate cluster number which we can decide now.
Right.
What in a case where we cannot decide the clusters? Like what if we try with the 10? Then we again have to try with 15.
Right. That is where your elbow function comes into use, isn't it? Elbow case.
Yes. Yeah,
Mhm.
yeah,
Okay. So what we want is we want cost of the clusters, right?
correct. Cost function of the clusters. Yes.
Uh,
We import the cost arrays.
yeah. So accuracy. So
Yeah,
let's
cost
see.
accuracy.
Actually, okay. Can you give me 2 minutes? I'll just be back from restroom. Just 2 minutes. Huh?
Yeah, yeah,
Yeah.
sure.
Yeah, just want to check one thing. K-mean score. Uh, this is the cost of the cluster. Okay, so let's do one thing, Rupesh.
Yeah.
So if I try to reduce the number of clusters, right?
Yeah.
In
Okay.
case I don't know, right?
Mm.
Okay. The cost further reduces. I mean, it cause score becomes further negative, right? If I increase this,
Mm. Even more negative.
right? So if I make it 5, say 6, 5, the objective is to bring it close to 0.
Correct. Yeah.
So right, so I think if we try with all the possible combinations, let me print it here. Let me try it. Right, I have not done it before. Let me do it actually. Okay, like we will print for all possible options. Okay,
Mm.
for because we generally do it other way. Let's try this way. For I in range 1 comma 10. Okay, K means you just keep changing number of cluster.
I. Not fitted error.
Hmm? K means for I have to fit it. Do you see it getting reduced?
Yes. Yeah.
Yes. Yes.
And if I try to 20,
Increase. 4.
First, like first 2 or 3, it is reducing very fast.
yeah. So see, what you have to do, you have to find the best point of division, right? Okay.
Yeah.
Okay. So see this here.
Base point of.
I mean, you remember the graph that we are plotting?
Yeah.
Okay. If you want, let me plot graph also here. Huh? Wait.
Copy.
Okay. So import math python percentage. inline.
That is LIBT. Yeah.
So after this, PLT.
No. Store it in an array and then plot.
Huh?
Store it in an array and then plot.
Yeah, or X and this is Y maybe, right? This is I is your, yeah, I can actually store it in, right? Okay. I is anyway, and cost is equal to this cost dot append. Then plt dot plot range 1 to 20 cost.
Give another bracket there. Task dot append. One bracket is missing.
Bracket, oh yeah,
Task dot append.
yeah.
There is missing.
Right, you can see till this 10 point it is steeply increasing. After that it is very gradual, isn't it?
Yeah.
Yeah. Yeah.
Actually I should have plotted the reverse way. Actually it's negative, so let me do one thing.
Remove print. It is taking time.
I wanted to show you the elbow. It will print now actually. The elbow. Got it, right?
Okay.
So you can see after 10 there is a sudden jerk.
Yeah.
Okay, so this elbow thing is coming here, right? So you realize that 10 is a good way to separate out. You can see the steepness here, and you can see the steepness here. Understood, right?
Understood.
Okay, let's proceed further. Clear?
Yeah.
Okay. Now the next thing is mostly about color compression. Okay. So I'm loading this image. It's very simple case actually. I'm loading this image. So what you have to do, there are a lot of colors in this image, right? Okay. So what you have to do, you have to basically, you have to basically find the mean color. That means there are some 16,000 colors here. You have to find out three colors by which, like, if this is the image, you have to convert it into 3-color image like this in the right hand side. Understood, right? So you have to find 3 mean colors.
Okay.
Understood, right?
Yeah. In that case, any of the image it will convert like this through the coding.
Yeah, any of the image. You can give any of the image. It will actually provided that image is in the form of raw image, so that it's not compressed. Okay. Okay. So it will find 3 colors by which it can represent this entire image. Okay, you can see the blue shaded thing becomes like this, one color. The the red and all these things became one color. The black shade. So you can see this is for image compression, these sort of things are extensively used. Understood, right? So first you compress the colors, then you can represent these all means one color. So you can represent this area is equal to color number this. That is how you do image compression. Understood? Okay, now let's see. We have this image which is like, if you do a shape of it, it is 427 cross 640 cross 3. That means 427 640 is the pixel size and 3 is RGB. One layer for R, one layer for G, one layer for B. Clear?
Yeah.
Okay, so now generally whenever you are doing image compression, you have to divide it by, you have to make sure the values are between 0 to 1. So you are dividing it by 255.
255 is not like, after checking the data, I have to decide what is the number to divide it by.
Yeah. Actually, pixels, I mean the color, right? It will be between 0 to 255. Okay. So you will divide it by 255 so that you get values between 0 to 0 and 1. Fine. Now what do you want? This all, like these all vectors are nothing but pixel RGB, 3-dimension, right? So the 3 layer means 1 dimension, one thing for one element for each layer will consist of 1 pixel, isn't it? RGB. Fine. Okay, so see this, you have 3 layer, 1 layer, 2 layer, 3 layer. This is your R, this is your G, this is your B. Okay, this entire thing is of 640 cross, this is your height, and this is width is called 427. Understood? Okay, and this 3-dimension. So you pick one data from here, one data from here, one data from here, you get 1 pixel. Okay, clear?
Yeah.
So any image can be of 3-dimensional.
Every image is like this. Every image is like this.
Every image is like this. Yeah.
Okay, this is how we do image processing actually. Okay, now what you have to do, you have to find 1 pixel color for, you have to find of all those possible pixel colors to mapping 1 pixel color, isn't it? Okay, all those possible pixel colors to 1 pixel color, that is what you have to do. So now to do so, what you have to, you're passing number of clusters 3 because you want 3 pixel representation out of all that. And what you're predicting for all the pixels which are similar color, that is light blue, dark blue, all those similar color, it gets classified into 1 pixel, right?
Yeah.
Okay, because what you remember, you're not finding mean of vectors here, you're finding mean of pixel colors here.
Right.
Okay, you're finding mean of pixel colors here. So you effectively found 3 colors.
And we are making 3 clusters.
Right. So after making 3 clusters, you get cluster centers, right?
Yeah, centered.
So what will you do? Basically, for this blue or this blue, right? This blue or this blue. Okay, you will for each position, this and this, you will replace it by the mean blue color, mean color of the cluster. These all will belong to same cluster, isn't it?
Right.
So you will replace that particular pixel color to with the centroid's color, isn't it?
Yes.
That's what you are doing in this case. Understood? The same way as you can revisit. You can go through the code. Actually, this is the only part that is interesting, but it's simple. So cluster centroids are there. If you part 1 and 1, you will give you 1 and 1 data. So here you will pass the cluster centroids for all the pixel, and you will get the new cluster colors, isn't it?
What is that?
Yeah.
Can you repeat again? What is it? 1,1?
This is the cluster centroids, cluster centers, right? This will give you cluster centroids. Okay.
Yes.
So the value of this is three, this sort of thing, three RGB, three types, isn't it?
Hmm.
Right? Three possible things. So this will be 0, this will be 1, this will
This
be
will
2.
be two. Yeah. Yeah,
Okay.
what that was
So when you pass, I mean, this is just an example. When you pass 1 comma 1, you will get whatever data is here, right? 1, 2, what,
yes, yes.
right? You will get that repeated. Got it, right?
Mm-hmm.
Similarly, here, what is the output of this image k means predict data? It will return you cluster number for all the pixels.
Yes. Yes.
Okay, so that is what you are passing here. So the resultant will be, a new color. That means where each of the pixel is replaced by the by the centroid of the cluster
Then,
which it belongs. Right.
yeah, yeah, yeah.
Okay, so that is what happens here.
Mm-hmm.
Understood?
Yes.
Okay, that's with k means.
Can I
Okay.
do the reverse case?
No, no, no. Reverse is not possible because once you do this, your information is lost. Okay,
Yeah.
that's
Yeah, that's
Right.
right. So you
Yeah.
cannot do reverse. You can do, a lot of other techniques are there, like, I mean, but there is no, correct method to do reverse. Fine.
okay.
So I'll just upload the code.
And during the code, the lines are going like that. For example, after line 40, it comes line 21. After that, line 5. Maybe after that, line.
So that is because
Uh,
the way I'm executing now. Okay.
okay. Okay.
Once you download it, since we have run through the code, if you face any difficulty, you should be ideally able to fix it. Otherwise, let me know. Okay.
Right. Sure. Sure. Sure.
Okay, so have a nice time. Tomorrow, I think Amitesh will get in touch with you to see, when can we plan one class, because next week will be off. We wanted to do one class. Okay. More or less, we are done with the two topics is pending. Okay, so little advanced topics. Okay, so go through it. Let me know if you face any problem. Start solving Kaggle. Huh?
Okay.
Okay, chalo. Have a nice time, guys.
Yeah. Have a nice day.